maybe just to start, I think that the usual thing to do would be give us a little bit of your background or of your story or how you came about to where you are at the moment.
Yes, sure. I graduated from mathematical faculty of St. Petersburg University, but I never worked as a mathematician. I have a degree in applied mathematics, but during my studies, I began to work as a software engineer and work mostly in Java development. And later I came to solution architecture, and now I'm going between solution architecture and software engineering. And 2 years ago, I started to work with Kafka. And I continue working with Kafka because Kafka is very popular, and probably I would do something else, but there is a great demand on Kafka. So for the last 10 years, I work as a Kafka engineer. And 2 years ago, I was approached by many publishing publications about the idea of creating a book. And the first idea was to create the new edition of Kafka in Action book. But I have very different style of explaining things, so I declined. And we had several meetings, and we came to the idea that it should be another book, Kafka for Architects, explaining Kafka without any code. And so that is how it all began.
I see. Well, yeah. So how it's surprising to me that I think that I always think about mathematical backgrounds, how useful that is, and how interesting is the people that actually know how to think is in those terms. Which I would assume that that probably helps you a little bit on your job.
Yes, it's very useful because it forces you to think at the very abstract level. So you always create mathematical model first, and it helps a lot in software engineering, especially in architectural questions.
That reminds me to Leslie Lamport that he always say that his best trait is abstraction.
Yes, that's
He said like I'm really good at that, and well, so about Kafka, maybe I was thinking about can Kafka lose messages?
this is the very fair question. And I hear it a lot from the customers. We have distributed pipelines, so can we lose messages? And the short answer is if you configure everything correctly, then you don't lose messages effectively. But you need to look at the whole pipeline. So you have producers, and producers send messages, and they must acknowledge that the message was successfully sent to the server only after the message is replicated to all the brokers or to all the synchronous replicas, which are required. And you also have retries. So if you send messages and there is a transient failure, then the producer just sends messages again. And luckily, this is the default configuration. And on the broker, you should enable replication. So you always have several copies of the messages. And if one broker goes down, then you are not afraid of losing the message. And if there are not sufficient brokers, then you just receive a failure. So if there are not sufficient brokers, this is mean in sync replica configuration, then the message is not considered to be sent. And on the consumer side, a similar story. So the consumer should acknowledge that it has processed the messages only after it really processes it. So process messages first and then send acknowledge. And this is actually not the default configuration. So this should be implemented on the side of the consumer. And if you configure everything on every side of the pipeline, then you don't lose the messages. Kafka is designed to be very durable.
Okay. So you need to do the replication, you need the retries, and then you need in the auto commit that is under default on the client, on the
You need
consumers.
auto commit and commit messages explicitly.
Yes. Don't trust.
Yeah.
Yes, the things are gonna go so well. Nice. That's good to know. Now we can rest assured Kafka is there for us to help us. And so another question. When I read your book, I I didn't know anything about the async API, and I thought that was pretty great. And Would you mind to explain a little bit? Do you want to show? I can show it, or maybe not even show nothing. And how do you feel about that?
Yes, sure, I can explain about it, but Kafka is well known for transferring messages, but it does not help much in data governance. And if you have distributed pipeline, producers, brokers, consumers, and different teams are responsible for these parts of the pipeline, then they need to define agreements somewhere. The structure of the message, the name of the topic, who is the data owner, who is allowed to consume the messages, and all these agreements need to describe somewhere, and there is no native proven solution for it. And one of the ways how to describe it is use async API, and async API allows you to describe these contracts in a very abstract way. So it's not about Kafka, it's about any event-driven system. So you just describe everything on the different level of abstraction. So publishers, subscribers, channels, operations, and only after that you map these things to Kafka. And it's a good proven way of describing asynchronous communication, but the side effect is that it's very verbose. And if teams know they are stuck with Kafka, they often choose the simpler variant, so the proper format. But the important thing here is that you need to define these agreements, these contracts somewhere. And if you need a really open formal way, then async API is a good way to go.
Okay, so if I remember correctly, it's like a YAML kind of thing that where you define the queues that you have or the
Yes.
topics that you have,
Yes.
consumers.
You create a text file describing all these things, and after that, you will store it in Git repository, and you will have CI/CD pipeline going, looking at your contract and deploying these artifacts into the Kafka cluster.
And then I'm curious about how can that get out of sync, because it's always like documentation. It's not enforcing anything, isn't it? It's just a recommendation. Please follow this schema.
Yes, sure, but a recommendation works when there is a technical engine behind it. So this is the responsibility of your CI/CD pipeline, just to ensure. And there are always kind of actions that you just do not deploy everything you have, but you can also see the difference, because you cannot forbid the administrator just to go into the cluster and create topics and change configuration. But in CI/CD, you should also think about watching for the differences. And the good idea is to have a kind of the report in the end of the day showing how your configuration confirms to the actual cluster structure.
Okay, yeah, that totally makes sense. That reminds me a little bit to Kubernetes for some reason. That idea that you have a desired state
Yes.
of the system, and that you, but maybe just like a follow up in the CI. Do you see? Um, I mean, because you said like there is a report at the end. It's just everything that you see is it maybe I would say like even enforcing something like you want to upgrade the version of a schema or something, and if the async API doesn't say so, it will block the CI. Have you ever seen such a complex scenarios?
It's not complex scenario. It happens every day. And actually, you mentioned upgrade of the schema, and upgrading of the schema is a complex procedure, because the schema of the message is the data contract, and the data contract evolves over time. And so you are required to change it, adding attributes, removing attributes, changing the structure of the message. And the idea is how it's compatible with the changes. And compatibility in terms of Kafka means that either you have backward compatibility, it means that you upgrade consumers first. So you have old producers and new consumers, and the old producer sends the message in the old format, and the new consumers need to process the old message. So this is the backward compatibility. And forward compatibility, it's vice versa. You upgrade producers first, so you have the new producers and the old consumers, and producers send the new message, and the old consumer should be able to process this message. So this is a forward compatibility. And if the changes are compatible, so if the new or old consumers can process the messages they receive, then it's smooth process. It doesn't require any downtime. It's okay. But unfortunately, you cannot explain to the business guys that you cannot introduce these changes because they are incompatible. So you will have incompatible
Fair enough.
changes. And this is more complex process, and typically you cannot process it just with running CI/CD pipeline. So you need to stop producing the messages, ensure that consumers process all the messages, then upgrade the schema, probably adjusting the compatibility level, and then upgrade the application. And this is actually a more complex process, and it needs to be established and tested, and all the teams should know how it happens.
Right. And do you see this process of stopping the service? Because I can imagine already the project manager just scared or not willing to have that on the system and how to explain that to stakeholders even. But what do you
Technically, it requires downtime. So if the changes are not compatible, but anyway, the teams should be prepared for that because this is the very common requirement from the business, just to avoid the schema contract in an incompatible way.
do you see more often one or the other? Like the downtime is rare, I would say, but or
Mm,
not that rare.
no, it's not rare, but we are talking about asynchronous communication. So typically, the client is prepared not to receive the message as soon as it's available. So there can be some delay.
Yeah. That totally makes sense. Okay. Nice. Well, good to know. Um, then another question that I had, it was about rebalancing, and it's if you can explain a little bit what that is. And for me, it's always that I kind of scared of if things are going to go wrong when rebalancing happens. But please, if you explain first what that is.
You have consumer applications. So typically, you have several instances of the consumer applications, and every instance of the consumer has some partitions assigned. And if a consumer goes down, for example, the application fails, crashes, or it can be also manageable shutdown, or vice versa, when the new instance of consumer joins the group, then the structure of the consumer instances changes. So you have probably more consumer instances or less consumer instances, and the partitions needs to be redistributed. And this is called rebalance. And it can be time consuming in terms of high throughput systems. But luckily, with the new protocols, it's not kind of stop the world process. So in the older version of Kafka, the typical situation was that all the partitions will be revoked and all the partitions will receive new consumers. And it will require the time that application just pauses processing. But luckily, in the newer version, it's much less of a problem because on Kafka moves only partitions which are not sane, which are required to be moved. So nowadays, it's much better.
So should I not worry? I mean, so if I have too much throughput, I will probably suffer. Is that what you're saying, that I will see a dip when rebalances happen, but maybe not too much, or
It's not about throughput, but it's about the stability of your consumer group. So the kind of anti-pattern for Kafka when consumers just join and leave the group frequently. And this will cause that the structure of consumer group changes and rebalance happens. So your consumer group should be stable.
should. In general, it is, I think. Okay. So it doesn't lose the messages. It's stable. We like those properties for sure. Yeah, let me see, because I had like another question here. Maybe we talked a little bit about the schema version. So how about how to select the number of partitions?
It's a very good question. It's partition is a unit of scalability. It's also the unit replication, but scalability is very important. And basically, if you know the throughput for the topic and you know the throughput a single consumer can process, then you just divide these numbers, so the whole throughput to the throughput of the single consumer, and then you will receive the number of partitions. But the problem is that you don't know these numbers in advance typically. So you need to rely on benchmarks, load tests, probably personal experience from other teams. And the general advice here is to perform some testing. And also, do not just calculate the number of partitions for each topic. So it's better that you have kind of types or categories for the topics. For example, a topic with a small rate. Here, for example, the updates of the clients, they do not happen very often. So this is an example of the topic with a small rate, and probably medium rate topic. Here, for example, we can assign transactions, payments, so on, and high throughput topics. And here go telemetry data, kind of user behavior, statistics, and so on. So the topics with high throughput. And then you choose the number for each of the category. And after that, you assign your topic to one of those categories. And this will simplify operations a lot.
Okay, so I just try to remember this function that I saw. It was I guess you mentioned at the very beginning. So you the desired throughput that you want, like say 1,000 requests per second or messages per second, and they say, well, okay, if I put 10 consumers, um, it will be that like I divide like by 10. I need 10 partitions for that. Is
If your consumers can process with the rate
100.
100, then you will need 10 consumers. But the problem is that these numbers can also change in the near future.
Exactly.
So it's better to have some buffer already imagining.
I see. I see. Okay. And right. So I think that you say something important there. That is that you have different topic for different um, messages, which is different flavors you can have from Kafka. Some people decide to put in the same topics different messages. Is that possible, or you always recommend to have each topic is just one kind of message and one kind of consumer, so you have the slow, medium, and high throughput?
It's not about the rate, and the general pattern is that messages of the same type go to the same topic. And this will simplify a lot of the application of the application processing, because you can also have some kind of stream processing there, joins of the messages, mapping of the messages, and these pipelines of streaming are better done when you have messages of the same type of the topic. But there is also pattern of polyglot topic when you have different types of messages in the topic, and mostly it's connected with the ordering, because you do not have ordering in the whole topic. You have ordering only in the partition, and ordering is important sometimes, even for the messages of different types. For example, you have client created message and client updated message, and the ordering is important here. And to have
Yes.
this ordering, you put the messages of different type into one topic and into one partition for the same key, so that consumer receives the messages in the proper order. So this is the case.
Right. Yeah. Important to remember that one. Right. Like the order is all only per partition.
Yes.
Be careful with your keys
Yes.
in that case. Oh, yeah, yeah, yeah. This is maybe that's a weird question, but I always wonder because they say, well, you can store as long as you want data in Kafka for months. And yeah, from my experience, not really. It's not that anybody wants to do that, but I was curious, like to see what's maybe the longest that you saw in the field storing data in Kafka.
It depends on your case, of course, and mostly it depends on how long you can afford your consumers to be offline. So it connected to the service level agreement of the consumer. And the important principle here is not to delete the data before all the consumers have had a chance to process it. So, for example, if your consumer can be down for 1 day, then you should keep the messages at least for 1 day plus some safety buffer.
That makes sense.
And the default retention is 7 days, and it's very long for production. So typically, you will not have such long retention in production. It's shorter, let's say 1 day or 2 days. And interestingly, in development environment, it's longer because applications are not developed yet. Testing requires time. You need to reproduce some cases on the data. So in development environment, it's 7 days. It's a quite good number. And also there are special cases. For example, for audit purposes, you may want to store the data forever, just to have the whole history of updates. And there is a special case, compact topics, when you have always the latest value for each key. So the answer is that the longest retention is forever.
Forever. If so, you saw those auditing ones, and maybe for the compact, maybe you can then elaborate on what that exactly is. But like forever, actually, you need auditing. It's not going to a database. They store it in Kafka and they keep it there.
Yes, it's not a very common case because, of course, there are cheaper storages. So you will export the data periodically there, for example, but it's actually a valid use case.
See, I see. And then you just mentioned the compacted topics, which I had no idea they existed at all. And but what that is and why people use those things.
Kafka is known for transferring messages, but there is also a use case when you use Kafka as a storage. And uh, this is where the system sends the messages, and the messages in Kafka, they have key and the value. And for each key, the latest value is retained. And the classical example is customer relationship management. It sends the updates about the client data. And the key here is client identifier. So the key is client identifier and the value is client data. And the downstream consumer, which consumes the data from the topic, it's typically interested in only the latest value. So the intermediate updates can be skipped. And this is the compacted topic. So it's a configuration of the topic. There is a periodic process on Kafka brokers which just compacts the topic. For each key, it just removes the old values and the latest value is retained. And this is the use case for event sourcing. So your consumer application, it may use Kafka as a source of truth because it effectively turns Kafka into a kind of key value storage. So your consumer applications starts and it can read all the data from the Kafka topic. So for each key, it will have the latest value and then use it in memory database for its own purposes.
I might be wrong, but just when you were explaining it, I thought that, of course, the key value store that seems like is it solving the caching invalidation problem, which is impossible, I guess, to solve. But since you get this stream of new values all the time, every single time that you ask for the last one, you will get the last one actually. So
It's a key value storage which is read sequentially, and after application reads its state, then it receives updates continuously. So it's on the side of the consumer application to deal with this cache.
interesting. All right, and okay, so I have this question about the batches. I think we are almost just finishing, but about the the size, which I think is very interesting. And when you start to tweak the size of the batches, the time that that well, I think that it needs to batch the group of messages to go from the producer to the broker, then to the broker to the consumer. And would you elaborate maybe better than I just did? How can you tweak and what do you see on the field on those properties?
Yes, we are talking about messages, but Kafka never sends messages one by one. So it always sends batch from producer to the broker, from broker to the consumer. And Kafka is optimized for the latency by default. So the messages are sent as soon as they are ready, just not waiting for additional messages to add to the batch. And on the producer side, it doesn't mean that messages are sent one by one, but it means that there is no idle period on the producer side, for example. So once producer doesn't have anything to do, it just sends messages. And this is the batch size, but for throughput, you will want to have better, bigger batches just to optimize the transferring. So it makes sense to wait some additional time. Probably new messages will arrive and they will be added to the existing batch. And so this is the configuration of the producer, the size of the batch, maximum size, and how long to wait for additional messages. And also the very important parameter is buffer memory, because these batches are made on the client side, and it should have enough memory just for these batches to be stored on memory. And the same on the consumer side, a consumer receives batches from the broker, and if consumer is optimized for latency, then messages are sent as soon as they arrive. And if there is optimization for throughput, for example, for topics with a lot of data, logs and statistics, which don't require latency, but there are a lot of messages there, then batches should be bigger. And on the consumer side, there is also important configuration is how many messages a consumer can process when it receives the batch, because there is a configured timeout. So consumers should ask for the new messages in a specified period of time. And if they do not, so they can not catch up, and then they cannot process the messages in the defined time, then the broker thinks they are stuck and they will be kicked out of the consumer group. So this is a very important configuration. So that consumer, how many messages will arrive to the consumer so that it can process it successfully.
Never heard about one. Okay, okay. So definitely important just to know if you're optimizing for latency or throughput
Yes,
and
this is
and
the
and
definition, yes.
make the batches bigger, do the milliseconds smaller, depending on what you want, right? Okay, okay. So I have just two more questions, and one is about Kafka streaming, what that is, and if you see there is any other alternatives to that.
Uh, yes, it's a very important question because Kafka becomes a commodity now, and streaming is where we have challenges. And your producer sends data and your consumer receives data from the broker, and nothing happens in between. And brokers, they cannot perform any logic on the messages because they do not know what's inside. So they never look inside the message. They don't know the content. So this is the pattern which is called smart endpoint dump pipe. And here,
Yeah.
broker is a dump pipe, and the dump in a good sense, because this is actually the reason Kafka is so fast. It doesn't care about the content of the messages. But sometimes you need some transformations. Transformations can be done on consumer side, of course, but probably your consumer is an external application, and it just expects the data in some format and you are not allowed to touch it. Or probably these transformations are reusable for different consumers. So you need to have some logic in between in this pipeline. And so how it's done, you create an application which reads the data from the topic, processes the data, for example, maps to different format, and sends to another topic which the end consumer consumes from. And these applications are created with special frameworks. And one of these frameworks is Kafka Streams. It's a Java library. So it provides you a lot of useful constructs for filtering data, mapping data, aggregations. You can even perform stateful operations, for example, calculating the number of messages per time unit and so on. But the trade-off is that you need to create Java application, and there is a demand for simple transformation. So you just do not create special servers, and you create kind of SQL-like language for transferring data. And these SQL transformations can be actually very complex. And another possibility is to use Flink framework, which is very popular now. So in Flink, you can create applications with Python or Java, and you also have Flink SQL. So you just have SQL query, which transforms the data, for example. So this is actually a viable variant for now.
Yeah. I think that is especially looks to me that if you want to do windowing, right, like you say, like looking in a specific time frames that you just mentioned, you better have some tooling around it.
Yes, there are a lot of useful constructs, and the new steps, you can even have a machine learning model embedded into the pipeline. So it's
Of
actually
course,
very
so
powerful.
you can have AI now everywhere. That's
You
nice.
can call your AI engine in between and so on.
That sounds good. And maybe just the last question is about Kafka Connect. That what that is, and or maybe again, if you know, maybe not alternative, but any special bad or good practices on that.
Kafka Connect is about connecting systems with Kafka without programming. And so far, when we talked about producers and consumers, we assumed that they are applications. But the idea here is that you can just configure the data transferring. So you have a database, for example, and you just say, I want this table to be transferred into Kafka topic, and vice versa. You have Kafka topic, and you just say this topic will be transferred to the data lake, and without programming. So you don't need to pay to expensive programmers. And
Yeah.
here Kafka Connect comes in, and this is the server. And when I talk about Kafka ecosystems, a server means actually a cluster of servers. So you have Kafka Connect, you have special plugins for a database or for a data lake, and you just configure what you want to transfer. But of course, as a trade-off, configuring is not as powerful as creating custom code. So, for example, when you take the data from the database, you need to understand which data is fresh because you do not have natural ordering in the database. And you need to use kind of incremental identifiers, updates of the rows, kind of timestamps. And it's very hard to understand if the data is deleted because you can just cannot derive it from a usual select. So this is the trade-off. And on the side of the sync system, the common error is mismatch of the data types because you read data from Kafka and you send it, for example, to the database, and probably some integrity constraints are violated. So some fields are null, which are not required, which cannot be null, and the data types mismatch and so on. And you need to decide how to do with this record. So they probably will go to the letter Q, or your connector fails. And this is actually a very tough problem. But and of course, a trade-off also is that a lot of these connectors are on the commercial license, so they are not open source. There is a great marketplace for the connectors. For a lot of them, you have to pay. But anyway, my advice is if you consider such kind of data integration, then look at the connectors first. Probably there is a connector for a system, and it will simplify your development a lot. So all in all, it's a very powerful way of connecting systems to Kafka.
can imagine happens everywhere as long as you have the money to pay for the integrations. I see.
You can even implement your own connectors, and this the way people do not think about it. So, okay, we don't have connectors, then we will create the producer consumer applications, but you can create connectors. This framework is open. So just program in Java and you will have your own connector.
Do you see that? Yeah, people doing that. Yeah,
It's not very common.
not very common.
I do it myself, so for me it's a proven solution.
Oh, yeah, that's good to know. That's good to know. And okay, so these are my questions. I don't know if you have any maybe a question I didn't ask that you would wish I had asked, or
I think we are good.
good. We're good. Well, thank you so much, really, for coming here to talk to me. It's been a pleasure and learning.
Thank you very much for inviting me.
Thank you.